Ever wonder what's really going on in those few moments before you get a search result? We tend to think that search begins the second we start typing. But the real work, the really foundational stuff, that all happens way, way before. Today, we're going to dive into those hidden first steps, the ones that decide everything, and explore how a computer actually learns to read.
So let's just start with a basic question. When a search engine or any big information system first looks at a web page or a PDF or an email, what does it actually see? I'll give you a hint, it's not words and it's not sentences. It's something much, much more raw.
At first, it sees this, a sequence of bytes. To you and me, that's just gibberish, right? But here's the important part. To the computer, in this state, it has absolutely no linguistic meaning either. It's just raw physical data.
Now, that same sequence of bytes, after one absolutely critical translation, becomes the word hello. And that huge gap, the one between the raw machine code and a word we can actually read, that's where our entire journey begins. This is the very first hurdle a system has to clear.
Okay, let's dig into that first step. This is all about turning that raw, messy data into something we can recognize, a clean sequence of characters. The official name for this is character sequence decoding, and you can really think of it as the essential bridge, the thing that connects the machine's world of bytes to our world of letters and symbols. Without this step, nothing else we're going to talk about is even possible. It's a non-starter.
Now here's what's so wild. This decoding process, it's not automatic. The system literally has to play detective. For every single file it finds, it has to guess the file format, the character encoding, which is basically the secret decoder ring for the bytes, and of course, the human language being used. And if it makes a mistake on any of these, everything that follows is completely corrupted.
So let's say we did it. Our bytes are now characters. Awesome. But now the system is facing another massive, and I mean massive, architectural decision. What exactly counts as one document? And this is where it gets really fuzzy, because the real world is messy. I mean, think about it. Is an email one document, or does each attachment count as its own document? If you search a book, do you want the whole book back as one result? Or just the chapter? Or maybe just the single most relevant paragraph? The systems designers have to make a choice. And that choice, it's a huge trade-off called indexing granularity. If you define your document as being too coarse, let's say an entire book, a search for one little phrase will give you the whole book back, which isn't very precise. But if you go too fine, like just a single sentence, you might lose all the surrounding context you need to know if it's actually relevant. So it's this permanent, tricky balancing act.
Okay, so we've figured out what our documents are. The next logical step is to break the text inside those documents into its smallest meaningful parts. And to do that, we got to get our terminology straight because these distinctions are absolutely crucial. Take the sentence, machine learning is fun. Machine learning is powerful. The word machine shows up twice, right? That means we have two tokens of that word. But it's only one unique word, so that makes it one type. And then once we standardize it, make it lowercase, machine becomes the final term that actually gets stored. This difference between tokens, types, and terms is fundamental to how search works.
Now, this whole process of breaking text into tokens, tokenization, sounds easy, doesn't it? Just split the text by spaces. But no, not even close. It's incredibly complicated. What do you do with a hyphenated word like state-of-the-art? Is that one token or three? How do you handle USA or a date? And don't even get me started on languages like Chinese, which don't use spaces between words at all. Every single one of these is a special case. It needs a rule.
All right, so we have our tokens. We are now at the final cleanup stage, and it's called normalization. The entire goal here is to make sure that different versions of the same word, like run, runs, and running, are all treated as the same basic concept.
So why does this matter so much? Well, without normalization, if you search for the word run, the system would completely miss any documents that only use the word running. By grouping all these related forms into one standard version, we dramatically boost our chances of finding what we're actually looking for. And there are two main ways to do this. First, you have lemmatization. This is the smart, linguistic approach. It uses dictionary rules to find the true root word, or lemma. So ponies correctly becomes pony. Then you have stemming, which is a much cruder, brute force approach. It basically just chops off word endings. So ponies becomes pony, which isn't even a real word. Lemmatization is precise. Stemming is fast and aggressive. So here's a good way to see lemmatization in action.
It's kind of like it has a built-in dictionary and grammar book. It's smart enough to know that are is just a form of the verb to be, and that running is a form of run. It uses real linguistic rules to find that true root meaning. It's clean, it's accurate, and it's really smart.
And now let's contrast that with stemming. Stemming doesn't know any grammar. It's just a machine following a very simple rule, like chop off the ending of this word. So automation becomes autumn, and automatic becomes automat. No, they are not real words, but the system can now see that they share a common stem. It's not pretty, but it's often effective enough and a whole lot faster.
So let's pull all this together. Why have we spent all this time on what might just seem like a bunch of boring clerical work? Because these aren't just minor steps. These are the fundamental architectural choices that define the entire system from the ground up.
We've just walked through the entire unseen journey. Data starts as unreadable bytes. It gets decoded into characters. It's grouped into documents. Then it's broken up into tokens. And finally, it's standardized into terms. Only now, after all of that, is it even ready to be indexed for searching.
And this brings us to what is maybe the most profound insight of this whole process. The quality of your search results. It's pretty much set in stone before a single query is ever run, before any of those fancy ranking algorithms are even applied.
Think about that for a second. If you make the wrong call about what a document is, or you tokenize your text badly, no ranking algorithm on the planet, no matter how advanced it is, can ever fully fix it. The foundation you lay in these very first stages is permanent.
So the next time you type something into a search bar and you get that list of results back in milliseconds, just take a second to consider the invisible architecture that's at play. What hidden choices about documents and tokens and terms were made, maybe years ago, that are now silently shaping the information you see?